We're now going to look at driveline fundamentals and service. So we've looked at transfer cases, so now we're going to look at drivelines, how they operate, and how to measure driveline angles. So first thing we want to know is what kind of driveline is it? So we have what's called a constant velocity or non-constant velocity. So a constant velocity U-joint is something that's used in the front axle. A non-constant velocity driveline is one that we use from our transmission to our rear diff. Because as the angle increases, so does the speed of the driveline. So as it's rotating, the driveline is non-constant. It speeds up and slows down. So how the configuration of the vehicle is set up depends on what we have. So for instance, off of the transmission, we can have a single driveline to a steady bearing. Off of there, we can have another driveline that goes to the front diff, another driveline that goes to the rear diff, and then we could also have a driveline that's off of the PTO. Now, all of these are non-constant velocity type drivelines. So again, depending on the configuration of the vehicle, we can have multiple drivelines set up in order. So a few things that we want to take a look at. Let's first off take a look at just a single drive shaft. So one of the things with a single drive shaft is we have to look at making sure the drive shaft is strong enough so that it can withstand the torque of the engine, transmission, and into the differential. We can't have the drive shaft and a single drive shaft too long, or the drive shaft will start to whip as the speed increases. The other thing that we want to look at is the angle of the driveline compared to the transmission and the differential. So if we take a look at number one, which is the transmission, and say that the angle of the transmission is 0 degrees, it's level with the road. Then we take a look at number 3, which is the differential, and depending on what the angle of that is, will determine, and the length, will determine how long the drive shaft is and what the angles of each of the U-joints are. So one of the things is with the length is the higher the RPM, the less operating angle we want. So for instance, if we take a look at drive shaft RPM of 5,000, the maximum operating angle that we want is 3.2 degrees. Well, we'll go with 3 degrees. But as we slow the RPM down, we can increase the angle of the driveline without getting any vibration. But for instance, one of the big problems is a driver forgets to raise his airbags after leaving the loading dock. And what happens then is it changes the angle of the front and the rear diff. It tilts them forward, which increases the angle of the driveline, and it'll cause a vibration. Parts or components that start to wear out that can change the angle of the driveline. So if we end up with a vibration in the driveline, we want to be able to correct that. The problem may not be a problem with the transmission or differential. It might be something as simple as repairing the angles on the differentials or the transmission. When we get into taking a look at multiple drivelines, so for instance, again, we have our transmission, our front diff, and our rear diff, and we have drivelines in between them. Now, between the transmission and the front diff, we have a single driveline. And again, what we want to do is make sure that the length isn't too long, or we have to put a steady bearing in. But we also want to make sure that the angles are all within the specifications. We get into transmissions or auxiliary transmissions that have a driveline off the main transmission. These may all be short, And one of the things we want to look at is if the driveline is too long, we want to put a center support bearing or a steady bearing in there to prevent any of the driveline starting to flex. So as it spins around, as the speed increases, it will start to deform and whip, and that can cause a vibration. Some may require two center support bearings because of the length. Now, depending on the application, we also want to make sure that we guard these drive lines, especially if they're out in the open where something can get caught on them. PTO shafts is another thing that we should really be aware of, staying away from when a PTO is running. All it takes is that PTO shaft or that drive shaft to catch a piece of clothing, and once it makes one wrap, it's over, because you're never going to be able to overpower that. So always be careful when we're working on drive lines. So some of the things that we should be taking a look at, the components of a drive line. So off of our transmission, we're going to have a yoke. Now these could either be full rounds or half rounds, and we'll take a look at, if you take a look at this one, this is a half round, and number 10 is a full round. So a full round will have two bolts that hold the bearing cap in. A half round will have a strap. So for any time that we're pulling one of these apart, we're supposed to technically replace the straps on the half rounds with new ones. So we don't want the cap to spin. So we've got to pay attention to that. Then when we take a look at the drive line itself, we have a slip yoke. And the slip yoke's purpose is to allow the change of length of the drive line as the suspension is moving up and down. We need that length of that drive line to change. Now, drive lines are manufactured with a piece of tubing and then a yoke and also a stub shaft for a slip yoke. These are all welded together, and then once they're all put together, they're balanced. Now, we also have to do what's called phasing of a drive line, and we'll take a look at that as we get on a little bit further here. So these are full rounds. Again, we have two bolts that hold the cap together, one on each side, and these bolts have Loctite on them, and the Loctite on these bolts is to help prevent them from walking out. On the older style, they used to use a strap, and you'd bend a tab over to hold the bolt in place. Now, these drive lines, again, when they're cut to length, they're put in a lathe, they're machined so they're square, and then they're welded together, turned, and then balanced. Now, depending on the manufacturer, again, if we have a 3-inch drive shaft, the maximum length that we want is 60 inches. And as we increase the length, we can as we increase the diameter, we can increase the length of the drive shaft. Now, the other thing they want to do is make sure that once the drive line is all assembled and welded together, that we don't have runout. And we're going to use a dial indicator to check runout. And there's a thing called TIR, total indicated runout. So anytime you're checking the total indicated runout of a drive shaft, you're going to use a dial indicator. Now, you don't need to zero the dial. You can zero the dial indicator anywhere you want on the drive shaft, because the dial indicator may move below zero and above zero. And what you're going to do is add those two together to get your TIR, or your total indicated runout. Now, there is a maximum spec that you're allowed to have, and we'll look at that a little bit later. So once the drive shaft is all welded together, they put it on a machine and they balance it. And what they'll do is put balance weights on there to take the vibration out. If this weight ever comes off, we can't weld them back on because we don't know what the weight was. We probably can tell roughly where it was welded, but that needs to be rebalanced. So one of the things we also should be careful of is the tubing itself. The tubing is thick, but it can be damaged if you're trying to take your full rounds apart. You should never hammer on the tubing itself. We should always use a U-joint puller of some type, or if we're stuck, we can actually lift up the weight with a jack and get this to come apart. When we take a look at our universal joints, so a couple things is this is a half round and this is a full round cap, and you'll see that we have some never sees on the bolts. They don't use the clips anymore. And also we'll have 2 grease nipples. One of the things to get in the habit of is lining up all the grease nipples all the way down the drive line, and that's to make it easier for us so that when we go in to grease it, we don't have any issues. We don't have to rotate the drive shaft to do that. So make sure that they're all in alignment. When we're taking a look at our slip yokes, okay, one of the things people do is they'll pull them apart. Well, if we pull it apart and we don't mark it, we can throw it out of balance, because when they're made, they're put together and welded and balanced. And if we take it out and turn it 180 degrees, it may not be in balance anymore. The other thing is on the back of the slip yoke, there's a cap. Now this cap's going to have a little hole in the end, and that will allow the drive shaft to change length without creating suction inside. When we're greasing this, we'll grease it till grease purges out of the back, then put our finger over this hole until grease starts to purge out the front seal. This is to ensure that we get grease through all the splines all the time. If we ever have to take and split the drive shaft, okay, so we have to take the slip yoke off the drive shaft itself, we should mark it. We should also undo this seal and leave it with the drive shaft. Don't try and pull it apart and then slide it back together. We're going to wreck the seal. The other thing to be aware of is these plastic caps inside. On a brand new one or a used one, if we're taking a used one apart, sometimes these white plastic plugs stay inside here. So we want to make sure that each one of these 4 has it, and that'll help ensure that grease gets distributed evenly throughout the 4. The other thing is making sure all our needles and our seal stay in place. Now, when we're installing or disassembling half rounds, they're the easiest. That's why they have gone that way. Is you can undo number 2, the straps. Take the bolts number 1 off. Take the straps off and just take a pry bar and put it in between the front diff yoke nut and just pry back, and that should come apart. Making sure that when we go to reassemble it, that we clean our bearing cups, make sure there's no dirt on it. And then on the yoke itself, there's a retaining tab, and these caps will fit between that retaining tab. Make sure it doesn't set on top when we go to do the clips up or the straps. And once they're tight, there should be no gap between the strap itself and the yoke. Again, different types of slip yokes. If we take a look at this one here, the other half will probably be covered with a blue nylon, and that's just to help it slide easier back and forth. Okay, steady bearings. So a steady bearing is service for life. There's no grease nipples on it. We can't grease it. It comes with either a perforated rubber or a solid rubber. If you take a look at this one, it is a perforated rubber, so it allows some movement. The solid rubber ones don't. It also comes with 2 dust shields, 1 for each side. So one will fit onto the drive shaft, the other will fit onto the yoke. And when we do up the yoke, it will fit around this area here and prevent any dirt from getting in. So if we take a look, a little bit of never sees on the inside of the bearing before we put it together. Again, we might be the ones that are pulling it apart, and we don't want to have to cut these off. So we put our steel slinger on, our steady bearing, our other steel slinger will fit onto the yoke, and then we'll tighten up the nut, and that retains this steady bearing in place. Now, one of the things we have to do is, we had it all apart, we marked it before we took it apart, but we also have to make sure that we put the yoke back on so that these two caps are on the same plane. And that's called putting the yoke in phase. If this yoke here was put on out of phase, it'll cause a vibration because they are non-constant velocity U-joints. It will change speed, and that will set up a vibration that could take out the bearing in the front diff or vibrate all the way back up to the driveline and take out your high-low range synchro. So make sure that before you take this apart to replace this steady bearing, that you do mark it, take it apart, and make sure you put it back in phase. So once we take this apart, underneath these bolts and this plate, there may be shims. And those shims are to ensure that our driveline angle is set right. So a customer comes in and he's got a vibration. So we want to go in and we want to measure the angle of the driveline to make sure that each driveline has at least a half a degree and no more than 3 degrees when we measure them overall. And we're going to take a look at how those are measured a little bit later. But how do we measure it? Well, we're going to use what's called an inclinometer. So here's our steady bearing, and these are our shims that fit between the steady bearing and our support hanger. And by adding or subtracting shims, we can change the angle of our driveline. Now, new technology, we use now a digital inclinometer to measure these. The other thing we want to look at is the angle of the driveline. If you take a look at this one here, how nice and straight it is, well, this one has an angle to the hanger. So we got to make sure that when we put this back together again, that the angle is close. Otherwise, the rubber for the steady bearing is going to eventually work its way out, and we're going to have a failure. So when we take a look at driveline angles, there's parallel and non-parallel driveline angles, also called a broken back. So here, if we go on the center of the transmission and then the center of the diff, these two lines do not intersect anywhere. So this is what we call a parallel drive line arrangement. When we take a look at this, our front is parallel, but our rear isn't. They intersect. So if we take along the plane of the front diff and the plane of the rear diff, we'll notice that these will intersect. So these are intersecting angles on a drive line. Yes, we can still measure them and make sure that they're within the specifications. So if we take a look at, for instance, a slip joint here, so what we're going to measure is we're going to measure the transmission. Now, because the front yoke is on the same plane as the transmission, we can yet measure the front yoke. Then we have to measure the drive line, and then we have to measure the differential. Now, some of the differentials will have square tubes off the front diff. We can measure off there or off the yoke. So on the front diff to the transmission, we're going to have 3 measurements. Again, we're going to have the transmission, the drive line, and the diff. If we take a look at one with a steady bearing, we're going to have 4 measurements. We're going to have the transmission, front drive line, second drive line, and then the differential. The other thing we got to pay attention to is the housings, if they come out of alignment. So if the torque rod rubbers wear or something breaks, the first indication is that the tire wear will look off. Now, how we align axles will get into when we start doing frames and suspensions, on making sure that that is done properly so that they are in alignment and the vehicle is running down the road straight and not scuffing the tires. So looking at the alignment of a driveline, so again, if this plane here is on the same plane as here, they're in phase. But if it's off to one side, it's out of phase. And we want to make sure that our drive lines are in phase so we can eliminate the vibration. It's a quick, easy check. It's just a visual check. You'll be able to tell just by looking at a drive line if it's out of phase. So it doesn't matter whether it's one with a steady bearing or not, they're in phase. And again, making sure that they're marked properly. Now, we talked about TIR, total indicated runout, and how and where we can measure that. So what we're going to do is measure in these spots here. So on a 3-inch drive shaft, what we're going to do is we're going to clean the paint off of the drive shaft, and we're going to measure. So in D, which is the center, we're allowed to have a maximum of 15 thou of total indicated runout. C, we're allowed to have 10 thou total indicated runout. And B, we're allowed to have 5 thou. Now this is where the slip yoke is as it wears, this number is going to change. And this is where we set the dial indicator on a stand or on the floor, lift up a rear tire and just take the brake, undo the brakes, and just rotate the drive shaft. Again, make sure it's not near the weight. And we're just going to record what the driveline runout is. So a lot of the stuff we look at are visual checks. Again, if it's out of phase, is it out of phase because the splines are twisted? Or is it out of phase because someone has assembled it wrong? So we want to take a look at all of these visually. We're going to move it up and down to see how much play is in the slip yoke itself. Again, as that slip yoke starts to wear, our total indicated runout is going to increase. We want to check other components. For instance, the steady bearing. We can push up and down on the steady bearing and see how much movement we get in the rubber. We also want to check at the back on the differential and also on the transmission of how much up and down movement we get. One of the common things that happens is this retaining nut backs itself off. Now there is a preload on this input shaft on the pinion bearings. If this nut comes loose, that preload will disappear and we'll have a running clearance, which means then we can move this yoke up and down. So we want to ensure that all these are tight. Otherwise, that may be the cause of the vibration. They're quick, easy fixes. So when we want to remove a drive line, again, most of the drive lines on highway trucks are not heavy, but we also want to be careful when we are taking them off. For instance, on a 5-ton truck, we want to ensure that we block the wheels before we remove the drive shaft, because most of the time the parking brake is on the back of the transmission. We remove the drive shaft, that vehicle can roll away, and we don't want it rolling away on us. So we want to block the wheels before we even attempt to remove the drive shaft. So on the half rounds, again, if the person before you put it together made sure it was nice and clean and put a little bit of never sees on it, it's going to come apart nice and easy. If not, then we're going to have to use some type of a puller to pull the yoke apart, pull these caps off. Now, there are some special pullers we can use. We can use these with an impact and we can push them apart. If you're using this to push apart, make sure you put your caps on. We don't want to put this tool right on top of the yoke and damage the trunnions. When we're dealing with half rounds again, these straps should be replaced. These also have to be torqued up. So make sure we torque them properly, make sure that the caps fit inside here properly. On a full round, we want to make sure that this is clean and the caps fit in there nice and smooth beforehand, so that when we go to assemble it, it's not going to be tight. And if we go to assemble it and we've already checked to make sure that these slide in and out, we have a problem with the yoke being spread. Now when we take a look at a constant velocity joint, so this here we have two setups. We have two sets of U-joints together, and this will give a constant velocity U-joint. Now, like I said, when we're disassembling these, you can get a bar in behind this and just pop it off. Make sure you catch the driveline, don't let it fall on the ground. The other thing we might see on some of these U-joints is it's a retaining clip. And what it does is it goes around the caps just so that they don't fall off, because if they fall off and hit the ground, bearings might all fall out and trying to find them all. So just be careful when we're pulling them apart. Now, again, any time that we take a look at a U-joint, we take it apart for any reason, we should be inspecting the trunnions to see what kind of wear we have on them. So wear can be caused by a bunch of different things. For instance, if you take a look at number one, spalling. Spalling is caused by a lack of lubrication. They haven't been serviced. If we take a look at number two, it's end galling, which means that the caps are being pressed on there too tight. Now, the yokes are set with a running clearance, but if something changes for any reason, someone bends the yoke, they can go in too tight. Number three is brinelling, and brinelling is usually caused by a zero working angle between, let's say, the transmission and the front drive line, or the drive line and a steady bearing, or the rear diff. So we have to have at least a half degree of working angle on that U-joint, or we will get brinelling. And then number four, pitting is usually caused by getting water into the trunnion, and that's usually caused by not servicing the U-joint properly. The other problem we might see is having a U-joint that's being ripped apart. It's too much load on the U-joint and it just comes apart. Now, we talked earlier about the caps, making sure that the caps slide in. So there is another tool that we can use that we slide in through one and to the other, and if it slides through both of them, the yoke isn't spread, because if we take the yoke and we spread it a bit, the angle will change and this bar will not fit into the two yokes, so we know that we've got a bad yoke. If it fits in there, it's not an issue. So some pictures we want to look at of U-joints. So this is brinelling. You can see we have a lot of flat spots. So here's what they say that can cause it: excessive continuous torque loads, seized slip yoke splines, excessive driveline angles, or sprung or bent yoke. Now, more what I see that I find is no driveline angle. So the U-joint can't, as it's turning, can't move around. So it just sits there in one spot and it'll eventually wear a hole into the trunnion. When we take a look at a fractured U-joint, again, excessive torque loads, shock loads, or improper application is not big enough for the loads we're doing. Spalling, water contamination, improper lube type, and lubrication failure. Now, one of the things that, again, when we're working where we are, is having summer and winter grease. So summer grease is a little thicker, and winter grease is a little thinner. So if we use winter grease in the summertime, the viscosity of the grease might not be enough to lubricate these trunnions, and we could get premature wear. So making sure that we change up our grease between summer and winter. So burned U-joint crosses, again, lack of lubrication. Now the driver's going to feel this. He's going to hear a clunk every time he lets the load off. When we get fractured yokes, again, excessive torque, shock loads, or improper application. Now, how do we measure a driveline? So you've got a damaged driveline that's to the point where we don't know how long it is. So we have to measure this up in order to get one made. So what we want to do is, number one, is the vehicle has to be at the proper ride height. So if it's an air ride suspension, you've got to make sure the airbags are full. And then what we're going to do is there's type A and B, type C, and type D. So type A has either half round or full round yokes. And what we want to do is measure from the center of one yoke to the center of the other yoke. And that is the measurement that you're going to give to the driveline shop. And what they will do is they will set it up so that the slip yoke is the proper length. If we do it wrong and there's a slip yoke in there, we run the risk of the slip yoke coming apart or the slip yoke bottoming out. On type C is, let's for instance say it's an automatic transmission. So what we're going to do is go from the center of the yoke up to the face of the transmission, and they'll calculate what the difference is in there. And type D, again, automatic transmission with a flange style, we're going to go to the face of the flange. So those are the types of, again, how to measure them for the driveline shop. Now, greasing of drivelines, making sure that when we grease a driveline, that grease purges out from all 4 cups. If it only purges out from 3, we have to find a way to make sure that that 4th one gets grease, or otherwise it's just going to prematurely wear out. Sometimes just rotating the drive shaft, taking a load off of it. Sometimes you may have to remove a cap to get the grease to purge out of there, but we have to make sure that grease purges out of all 4. When we're installing a bearing cap, okay, so we've taken it apart, we had to change the seal on the front diff. So taking a piece of emery cloth and cleaning up inside the yoke and cleaning off the cap, putting a little bit of never seize on the cap, and then reinstalling it. Now, if A and B come apart, it's garbage because the cap's going to spin, it's going to wear out the yoke, and then it's going to be no good. Now, the other thing we want to pay attention to again is making sure that if we're reusing the bolts, we put some blue Loctite on them. Never use red Loctite on these because you have to heat that up. The other thing is when we take it apart, we want to check number 3, the seal. We want to make sure that the seal stays with the cap and it does not stay on the U-joint. Because if it stays on the trunnion and we mix up the caps, we're in trouble because then we have 2 seals on one and none on the other, and it probably won't fit together anyways. The other thing is the older style U-joints, we used to use these straps. So these bolts never had any Loctite on them. They were just put in, and then one of these tabs was bent over to retain this bolt to stop it from spinning and backing out. On smaller U-joints, we're going to use these clips, and these clips are there to hold these caps in place. So again, we're going to clean up these holes, make sure that they're nice and clean, make sure these are clean. Now with the smaller U-joints, we really run the risk of the needles coming out. So put a little bit of grease inside the bearing cap to retain the bearings, and then put it together and tap it together. Make sure that those bearings don't fall down inside or they'll end up on the end cap. And if we can't fit these clips together, there's a reason why, and it's usually because one of the bearings has fallen down inside. So there's special tools for making sure it stays in alignment as we assemble it. And again, we've already talked about ensuring that we line up our grease nipples. Taking a rubber mallet, tap the caps in, make sure the U-joint moves freely after we tighten all the bolts up. On the half rounds, taking a rubber mallet to make sure that these are seated properly beside the retaining tabs, and then put the straps on and torque the strap bolts up. Now, drive lines, how to measure a drive line. So again, we're going to use some type of inclinometer. A bubble level won't work because we need to know what the degrees of the drive line are. So the most common thing that we're going to use is called an inclinometer or an electronic angle finder. So what we want to do is we want to set it up to degrees, and we want to measure our drive line angles. So how do we do that? Well, we could measure off of the cap, but I've always found that it's easy to measure off of the frame or to the transmission. Now, we don't have to zero the inclinometer on the frame before we start. We can just start with the transmission. So doing that, we don't have to take the caps off the U-joints, and we don't have to make sure that the yokes are level. So if we measure the transmission, again, the top casting on the transmission is cut with at the same angle as the output shaft, so we can do that. So using the inclinometer, one of the things we want to make sure is we take all our angles from the same side. I always do mine from the driver's side transmission, driveline differential. Okay, so now that we've got our angle and on our inclinometer, and we're going to measure what the angles are. So we're going to measure the transmission. Engine transmission is 1 because down the center of the crankshaft goes right down the center of the transmission and out to the yoke. Then we're going to measure the angle of the front drive line, the angle of the front diff, the angle of the rear drive line, and the angle of the rear diff. Now what we want to do is we want to split this up. So if we're just doing, for instance, a single drive line, we'll start with that. So our single drive line starts with the output of our transmission, our front drive line, and our input to our front diff. So let's just say that our transmission is plus 5 degrees. So looking from the front of the vehicle to the rear of the vehicle, if the drive line or transmission slopes downwards from the front to the rear, it's a plus. If it goes up, it's a minus number. So if we have on our transmission, we have plus 5, our front drive line, we have plus 3, and our front diff, we have plus 4. So they're all positive angles. So what we do is we always subtract the largest or the smallest number from the largest number. So how we're going to do that, we're going to get this. 5 minus 3 is 2. 4 minus 3 is 1. And 2 minus 1 is 1. So we have 1 degree of working angle. Now each of these numbers again has to be at least half a degree. And these working angles should not be more than 3 degrees. So when we see plus 1, it's perfect. That's what we want. But we never want to see a 3 and a 3 because that means this angle is less than half, and it will wear out this and we'll end up with a vibration. So we want to keep these working angles as close as we possibly can to each other. Now, when we take a look at this, which is a broke back or non-parallel, so if we have a minus 2 and a plus 1, we end up with 3. So if we go minus 2, minus 1, 0, plus 1, we end up with a 3. So we add these together. But if we have a plus and a plus, again, we subtract. So it'll be 4 minus 1, which would be 3. So we end up with 3 degrees of working angle here. So it is less, it is greater than a half a degree. And we end up with 3 degrees here, but overall we end up with a net gain of 0, which is fine. We have at least 3 degrees on each one, or greater than ½ degree, and no more than 3 degrees on each one. When we get into compound gear ratios, or angles, what we're going to do is take the transmission, front drive line, and transfer case, drive line, and front diff. So 1 and 2 with this drive line will be one set of measurements. Number 2, number 3, and this drive line will be a second set of measurements. And number 3, number 4, and this drive line will be another set of measurements. And we measure them all differently, so not all together as a unit. Okay, working angle in degrees. We've already talked about speeds. Now, how do we diagnose vibrations? There are some meters you can put in a vehicle, and it will pick up what the vibration is and tell you where it's coming from. Is it happening all the time? So again, road testing with the driver to find out where this vibration is coming from. So simulate the conditions, record your findings, and then do some inspections. Check your tires. We talked about tires that are different in diameters, where again, we're allowed to have 3/4 inch circumference, 1/4 inch in diameter. Is there a rock stuck between the duals? Have we got a U-joint coming apart? Have we got a yoke nut loose? So drive shaft that's being damaged, out of phase. All these things we want to take a look at before we carry on. And again, if a drive line's out of phase, what's going to happen is it's going to work down into our front diff and take out that front bearing, or it can resonate all the way back up into our transmission and take our synchro load. And you can see the vibration, what it's done to these teeth, and it'll break off the pins off of our synchro inside the transmission. So we're going to spend some time in the shop, and I'm going to go through and explain how we do driveline angles a little bit more in depth. But for drivelines, that's it.